Today we are going to show you how to build and run V2 workflows using our new designer. So first thing we are going to do is come into the Flowgear console, looking at the workflows menu item. So we're just going to click here on new V2 workflow. So this is our new designer. What you can see here is we have a range of functions. Just going to close up the assistant pane and get started. So what we have here is our parameters and returns for the workflow. So this is our inputs and our outputs. First thing we are going to do is add a step. Now these steps are connectors, and we have a range of generic as well as specialized connectors. Specifically, we're going to look here at creating a query in Salesforce, since we are going to sync Salesforce contacts into Sage Intacct. So what we have here is our connection. So we're just going to open this up. This is now our credentials into Salesforce. So what we have here is a few properties you can set for the credentials. We also have our list of environments. This is the logical separators for the connections as well as the workflows, so that you can specifically target certain environments. So now we're just going to test the connection and make sure it works. Once we're happy with that, we're going to switch on back to the canvas, and now we're going to select this specific connection. So this is going to retrieve a list of templates. Now the templates is pre-configured schema for the specific operation we decide on. So specifically we want to look at querying contacts. So what this will do is give us a list of fields and a list of possible outcomes, and then we can map that accordingly. So this is now going to pre-configure our step. So at the top you'll see we have our inputs. So this is the connection we just tested. We also have our query. So once we open this, we can see there's a list of fields that we are specifically looking at. We also, just for this purpose, going to limit it to 10, but you can remove this limit in the future. So what this also means is that this specific workflow design can scale for any number of records. So next we have our list of outputs. Now I'm just going to go ahead and select our Sage Intacct step. So for this, we specifically look at the mutate method, since we now want to go ahead and create the contact in Sage Intacct. So we have that. Then I'm going to select the sandbox connection, since we have this pre-configured. We'll also receive a similar set of templates. Now each of the lists are specific to the connector and the operations available. Now we're going to select the create a contact template. This will now pre-configure our Sage Intacct step, so we can start looking at the mappings. Now the mappings are what shape the data from source to target. So specifically we're going to start by just dragging our response. So each contact from Salesforce we're going to create in Sage Intacct. We'll map some basic other fields like our last name as well as our first name. Then next we are going to map the email. Just going to search for that, as the schemas can become quite large depending on which systems you integrate with. Next, I also would like to touch on our expressions. Now, if you look here at the top, we have the value as well as the expression. So in the expression, you can provide the mappings as you can drag them across. We also have a list of functions. Now the functions, you can have transformations, calculations, and other types of functions. For this, we just want to create a unique ID for our Sage Intacct contact. Next, I also want to touch on the print as field. So we'll also use a function here. So let's first drag our last name into last name. We'll drag our first name in there as well. So what we're going to look at here is called the concatenate step function. So we're going to start typing, and we'll type in concat. And then we are going to concat our first name. After that, we'll add a space in between, and then we'll end with our last name. Okay, perfect. Now we are ready to run this workflow. A few things I would like to just note here at the top is our environment selector. So this is similar to what we have in the connection. So you can run it based on the environment you select here. So you can run it from test all the way into production. Then we have our clusters drop down as well. So if you're familiar with V1, these are the drop point replacements. enabling you to run a workflow completely on premise. We'll get onto that in a bit. So let's just run this workflow. What you'll see here at the bottom is the workflow log pane appear. This will show the results as the data is flowing from Salesforce into Sage Intacct. So first thing to note, we have our Salesforce contacts being queried. We received 5 rows, and then in Sage Intacct, we created 5 contacts from Salesforce. We'll just look here at the successful response, confirming that the data flowed successfully. One thing to touch on here is if we look at this rows, it prompts our lazy evaluation. So a lazy evaluation means we don't wait for the entire query step to complete. We process the data as it's been received from Salesforce into Sage Intacct. And this is also the point where we can scale this workflow design into any number of records, since we handle the paging and pagination for you. Okay, next I would like to touch on some of the features we have available in the designer. Specifically, we're going to start by looking at Infer all steps. Now, what this does, it detects changes from previous run data and gives you a more accurate schema so you can map data better. Now, we can see from our previous run, we have a schema that we can now apply. So I'm just going to apply that on both the Salesforce as well as the Sage Intacct steps. This gives you a more accurate representation of the data, and now you can map your fields according to that. Next, what I want to touch on is if we go back to our print as field, we are going to look at the preview function. So this is the live preview. What this does is based on the expressions you have, if you have functions or mapping data, this will give you a live preview of that data based on previous runs. So keep an eye there as we toggle this. Now you can see we have the result now showing up there. So this result has been determined based on previous run data by providing the first name and last name. You also have the ability to see this in the pane below, where we have our preview pane with our expressions as well as the result of those expressions. So you can access that on any step after it has been run. And this won't invoke the workflow, but just give you a preview of the data as the expressions provide. Next, we want to switch over to our code view. So we have a two-way binding, meaning that the canvas and code view are in sync. So whatever changes you make in this, you can see in the canvas view as well. We have some extra features here like syntax highlighting, some code folding, some autocomplete that will aid you in your development as you see fit. This also brings me on to my next step, where we have some error handling. So specifically, we have live diagnostics. So this diagnostics are compiled in real time without needing to invoke the workflow. As we broke this now, we can see that immediately we have a problem appear with some specific line item with a code as well as an error message. Now to get rid of that, we will just go back and fix the problem we had, and we should see this problem pane disappear. As we go, we can also do this on the canvas view. So it's not only a feature on the code view, but it also aids you while you're developing on the canvas view. So what we're going to do now is just break one of the expressions. Then you should see the problem appear again, showing that a specific expression has been broken. This is because we need to map the parent if you map the child. So we're just going to go ahead and fix that up. And then we should see this problem pane once again clear up, and we are ready again to run this workflow. This also leads me to my next step. So different ways of invoking the workflow. So we have steps called triggers. Specifically, we want to look at now is called the HTTP receive step. So if you add that at the start of the workflow, you provide a specific method and URI, you can enable this and run it as an API. So this can be invoked externally once you provide an API key. And you also just need a corresponding HTTP response step. So what you can add here is one of the pre-configured HTTP response steps. You can add some headers as well as a response body. And then this can be invoked externally outside of Flowgear. We also have other triggers. For example, we have the MCP receive step. So what this does is enables this workflow as an MCP tool. This can then be configured in the AI model of your choice, for example, OpenAI or even Claude. And then this workflow can be run via the AI model and invoke any nodes in this workflow. Next, I also want to touch on some of the other triggers we have. So we have a trigger called schedule. So the schedule invokes the workflow on a recurring basis. We have different methods. So we have the weekly, monthly, daily, as well as cron. So cron is custom. For this, we'll just select daily. So you can see we have a start time, we have an end time, we have interval of, for example, 2 hours that you can run this workflow. So everything downstream will be invoked at this recurring interval. Next, we also have what we call listen nodes. So listen nodes wait and fire when a specific event occurs. So specifically, we're going to look at the file listen, which watches a file or a folder and then emits matching files as they are created, modified, or renamed. So this is one of the workflows that would be run on a local cluster, and then you can watch a specific directory, and as the files change, everything downstream will be invoked. This brings me on to my next step. So what we want to show next is sub-workflows. So if you are familiar with V1, you know you can invoke a workflow within another workflow. We have the same ability in V2, but with another extra feature, you can actually invoke V1 workflows from V2. So once you have selected your specific step, you can now provide the params and map the responses accordingly. This also brings me on to local clusters. Since you can now invoke a workflow on a local cluster, you can actually invoke workflows across clusters by using the sub-workflow method. So here we are just going to switch over to our local cluster page. Just going to show you how you can download a local cluster. Once you've downloaded the installer, you can now run the setup and get it connected into Flowgear. You will need to create a local cluster here and add some environments. After you've saved that, you can go into that and go upload a trusted certificate. This certificate will be installed on the machine that you connect with. And then you can also have your list of hosts, so that will show all the hosts that's connected via the cluster once you can now invoke the workflow on that local runtime. Once you have that sorted, you can go ahead and select the local cluster as we've shown before and run a workflow entirely on premise. Next, I want to touch on our management features. Firstly, revision management. Here you can see we have a list of workflow versions with some details as to who saved the workflow, when it was saved. You can also open up this version in another tab where you can revert and roll back to a specific version in time. And you can also save a commit message to indicate what was changed in the specific version. Lastly, I would like to touch on release management as well. This is the ability to promote the workflows through to different environments as you need. Once it has been confirmed tested and you want to now promote it into the next environment, you can promote it through. We also have the ability to enable and disable workflows, as it has to be able to be invoked via one of our trigger workflows. Once you are happy, you can now go ahead and promote this workflow through. And then after that, you can go ahead and enable this workflow. Now it's ready in the next environment. This gives you fine control and the ability to promote as needed. Right. Thank you very much. That is the demo for today. Just showed you how to create Sage Intacct contacts from Salesforce. Thank you.
Thanks, Rick. Up to this point, we've seen how a person can build and run workflows in Flowgear. What I'm going to show now is the next layer on top of that, how AI can help with that same workflow building. The important distinction is that this is not AI sitting outside the platform and giving generic advice. In Flowgear, AI is being used as a governed accelerator. It helps you get further, faster, especially if you are new to Flowgear or not deeply technical. I'll show this in 3 stages. First, we'll stay inside the Flowgear console and use our built-in assistant to create and improve a workflow. Then we'll move outside Flowgear into an external coding agent and show how it can help build a Flowgear app and the backing workflow capability behind it. Finally, we'll use Workflow MCP to let the chat assistant call a finished Flowgear workflow as a tool during a normal conversation. We'll use one simple case study to anchor everything today. Our sales team receives new leads in Salesforce, and for each lead, we want Flowgear to generate a clean handoff brief, save it into Microsoft OneDrive, and track whether that upload succeeded or failed. That gives the sales team something more useful than just a raw Salesforce record. It gives them a readable profile, who the lead is, where they came from, their contact details, and a recommended next action. We'll carry that same process from workflow build to dashboard to chat. We'll start inside Flowgear with our built-in assistant. We're starting from a blank workflow. There are no steps on our canvas just yet. For a user who already knows Flowgear quite well, they could build what we want manually, as Rick demonstrated previously. But a newer user has a lot to figure out before they can even begin. Which nodes to use, which templates matter, how data should move between steps, and which connections are needed. I click our built-in assistant action button on the right here, which will open up our chat panel. And then I'll paste in our prompt, which describes the outcome in business terms. And that's going to let our assistant help turn that into a real workflow. Our prompt is intentionally business focused, and I'm simply describing the result that we want. So as the assistant starts working, notice that it's not just giving me instructions. It is discovering what is available in Flowgear, the nodes, methods, and templates, all in an effort to determine the workflow structure it needs to assemble. And then we reach an important moment when the assistant needs access to a real business system. It asks for which connections it may use. So I select the Salesforce connection and then the OneDrive connection. That matters because the assistant is not being handed every credential in my tenant. This is a key governance point. Access is explicit, and the assistant only works through the connections and tools exposed for this build. So now that those are connected, it can continue assembling our workflow for today. Now, during this sped up version, it triggers some discovery for the desired workflow shape, some test runs to validate results, and it maybe even retrieves some logs so that it can verify what it is building. You'll see that it also may hit some validation errors along the way. That is expected for this kind of build, and the useful part is that it can then use those errors as feedback and revise our workflow. And once it has a version ready, it then proposes the workflow, which I can review and either reject or accept. We accepted the assistant's proposal, and this is the first useful result. From a blank canvas and a simple request, we now have a workflow that can be inspected, run, and further revised. At a high level, it queries the latest Salesforce leads in this step, and then turns each one into a web-ready handoff brief, and uploads those briefs into Microsoft OneDrive in this step here. Let's give it a run. Now for this demo, I'm limiting to 5 leads, but in practice, it could be configured for a specific time window or whatever desired batch size. You can see here, it is pulling the 5 Salesforce leads and doing the processing and uploading for each one. There, it's all done. It's successfully processed and uploaded our 5 leads. We can go ahead to our OneDrive folder and give it a refresh. And we can see here the 5 Salesforce handoff documents that we've just uploaded. Here is what our handoff document looks like for today. So our first version works, but it is missing an operational layer. From an operations perspective, the workflow creates the files, but it does not yet leave behind a clean processing status per lead. we have some questions. Which upload succeeded? Which failed? And if something did fail, which lead did so? That is the improvement I'm going to ask our built-in assistant to make for us today. So I'm going to open up our assistant panel again and paste in another instruction here where we're going to ask our built-in assistant to keep the current Salesforce to OneDrive behavior exactly as is, but add that missing upload outcome tracking. The important part is that the assistant is working against the existing workflow. It inspects the current steps, proposes a targeted change, and applies it only after my approval. That is the agentic part of the build experience. It can act on the task, but the result remains visible, reviewable, and controlled. You can see here that it's given a nice little plan for its proposed change. It all looks correct, so we will go ahead and reply with our approval to go ahead with this plan. And then it will continue to do some work, the same procedure as before ultimately proposing the updated version of the workflow. And here is the version I accepted. The assistant has added a try-catch around the OneDrive upload. In the success path here, it records the Salesforce lead ID and the successfully uploaded OneDrive URL in a lead status key value group that's designated as a success. And then in the failure path, it also creates a key value record in that same group using the same Salesforce lead ID and the generated file name, which was unsuccessfully uploaded as the value. And you can see here it's designated as a failure record. It also raises an error so that the failed lead is visible within our workflow logs. So our original Salesforce to OneDrive process is unchanged, but now each lead leaves behind a queryable status trail. We can give this workflow a run, and we will see here that it's again going to be pulling our 5 Salesforce leads, and the success records are now going to be created for each successful process and upload. Perfect. So our built-in assistant helped us add this missing operational layer. It didn't replace the workflow designer, it accelerated my build inside of it. So far, the AI assistance has happened inside Flowgear, but many people already work with AI assistants outside the platform, in IDEs, desktop apps, or chat clients. So the next question is, can those external agents use Flowgear too? That is where MCP comes in. MCP stands for Model Context Protocol. The simple way to think about it is that MCP gives AI applications a standard way to connect to external systems. An AI assistant on its own can reason and generate text. However, for it to be useful in a business process, it needs controlled access to context and tools. MCP is the bridge that allows those capabilities to be exposed to the assistant in a structured way. The keyword here is controlled. When an external agent connects to Flowgear through MCP, it does not get uncontrolled access. It gets a defined tool surface through an authenticated MCP connection, and Flowgear still controls the integration work behind those tools. This MCP tab is where you find the setup instructions for those connections, including the one-shot setup prompt for Builder MCP and the configuration details for Workflow MCP tools. But let's take a step back. In Flowgear, we use MCP in 2 ways. The first is Builder MCP, which is about building. This is what lets an external agent create, inspect, update, and test workflows from outside the console. The second idea is workflow MCP, which is about using. It lets a published workflow become a tool that an assistant can call during a conversation. So the simple distinction is, Builder MCP builds integrations for you, Workflow MCP uses integrations. We'll start with Builder MCP and move out of the Flowgear console into an external agent. I'm using Codex via its desktop app with the Flowgear sample app project open. This is a skeleton project that allows you and your coding agents to easily get started with Builder MCP and AI-assisted building of entire Flowgear apps. It is publicly available on our GitHub, so you can clone it and try it out yourself. For example, if you are more familiar with an IDE experience, you could open this project in VS Code and make use of the various IDE extensions available, such as Codexes or Claude Codes. The key file here is this agents.md file, which is open. This is what gives your coding agents of choice all the project-specific guidance they need to be able to use Builder MCP and actually build Flowgear apps from this starter project. Now, Flowgear apps are lightweight front-end apps, but the back-end remains workflows. That means we can build a custom user experience without moving Salesforce credentials or OneDrive credentials or any of the integration logic into the front end. So in our case today, the app that we want is a dashboard for our Salesforce lead handoff process. All right, so let's jump back to Codex. We're going to paste in another instruction for Codex here. I'm asking it to create a Flowgear app for a Salesforce lead dashboard and to use Builder MCP to create any of the backing workflows that may be needed from scratch. The app we want is one that will show the latest leads, the overall upload health, any leads needing attention, and perhaps some sort of way to open the brief when one was successfully uploaded to OneDrive. So for each lead, we want it to be able to read the upload tracking from that very same lead status key value group that our built-in assistant helped us add earlier. So our AI-assisted improvement helped us add that missing operational state. Now, our external agent, Codex, is helping us build a business-facing app that makes that operation visible. So just as it got started, let's take a look at the type of work it is doing. It began by verifying that Builder MCP is registered and connected in this environment. So this is similar to our built-in assistant. We can see shortly that it will start interacting directly with Flowgear. It will list nodes, discover templates, create workflows, run tests, or retrieve existing workflows, such as the one that our built-in assistant helped us design. The front end and back end are being developed in the same conversation. For someone who understands the business process but is not a Flowgear specialist, that changes the entry point. The agent can help assemble the business tool, while Flowgear keeps the integration concerns in the right place. That is the bridge from ordinary coding assistance to agentic integration development. Our agent, Codex, is not just generating a static UI, it is building a custom app around governed Flowgear capabilities. Here is the resulting dashboard that Codex created. At the top, we have a latest lead card showing the newest Salesforce lead with some key lead details. Below that, we have some summary cards as well as an upload coverage visual in the top right, basically showing counts of the total leads, the successful and failed uploads, as well as anything not yet processed. And at the bottom, we have a searchable lead directory. Each row is a Salesforce lead, pulling all of the available context about that lead, as well as an upload status column and a brief column. Now, this upload column is especially important. It is using the lead status key value group that our built-in assistant helped build and improve earlier. I can actually go ahead and open one of these briefs directly from our dashboard, and that's going to be pulling live from our OneDrive folder the same business artifact that we created earlier. Now, this run button shows that Codex did more than build a simple read-only dashboard. When I run a handoff for a lead, let me choose one at random. What actually happens when I press that button is that the app invokes a Flowgear workflow that Codex created during our build. And that workflow is a simple backend workflow that processes a single lead and updates the dashboard with the result. You can see here that that was successfully processed and uploaded via our dashboard. We can go back to our OneDrive folder, give it a refresh, and we can see here the new lead that we just processed and uploaded via our dashboard. The important point is that this is not just front-end code. The front end is entirely custom, but the back-end integration work still lives in Flowgear. And because this is being built through the same agent conversation, I can keep iterating quickly, like changing this to a pie chart, adding some more per lead actions one can take on the dashboard, basically asking Codex to create additional Flowgear-backed capability whenever our app may need it. So this is not about replacing governance with AI. It is about giving AI a governed place to build. Builder MCP is about building integrations from an external agent. Now, let's switch over to the other side, letting an assistant use a finished workflow as a tool. That's Workflow MCP. Here, I have a small workflow prepared as an MCP tool. It reads the latest Salesforce leads and returns a clean response for an assistant to use. Now, this is still a normal Flowgear workflow, but it has been MCP enabled with an MCP receive step at the beginning and an MCP response step at the end. This MCP receive is also where I give the tool a friendly name. In this case, I've called it Get Salesforce Leads, so that our connected assistants have a clear tool it can call. Now, I assign this workflow to my user-specific MCP delegate key, which you can see here as the assigned workflows. This assignment controls which MCP tools my connected assistants can see and use. The assistant does not automatically get access to every workflow or every connection in my tenant. It gets the specific tool capability that has been exposed to it. Now, the design of the workflow controls how the assistant gets data, what it can return, and what actions it can take. But this delegate key controls which exposed tools and permissions apply. Now, I am in ChatGPT Web, connected to that MCP-enabled workflow that I showed previously. Now, various chat clients use different terminology, but in ChatGPT's case, they refer to it as apps. And this is how I reference our app. So I've named our workflow MCP connection this, and by referencing it, it is going to allow ChatGPT to see the tools that I have connected. Now, I can simply ask a question. I'm going to ask for it to tell me about a specific lead that we might have seen on the dashboard that Codex created for us. Now, we should see ChatGPT calling our Flowgear tool, getting the Salesforce lead information back, and then answering in natural language. So it looks like it did call the tool. It called our MCP workflow called get Salesforce leads, got that response back successfully, and it's given us a nice table all about the lead that we asked for. The important thing is that this answer is not coming from model memory. It is coming from live business context exposed through the Flowgear workflow being invoked as an MCP tool. That is the value of Workflow MCP. A workflow that starts as an automation can become an assistant callable business capability. Now, let's tie the whole story together. We used one case study throughout. Salesforce leads becoming OneDrive handoff briefs. We started by using the built-in assistant to create that workflow, and then improve it with the missing per lead status tracking. Then, we moved outside Flowgear into Codex and used Builder MCP to build a Flowgear app around the same process. And finally, we used Workflow MCP with ChatGPT so that a finished workflow could be used as a tool in conversation. Through this, we provide a controlled way to bring AI into integration work. We are not simply handing our assistants a pile of credentials and hoping that they build safely. We are giving our agents a governed integration tool set, defined tools, approved connections, workflow permissions, environment boundaries, and importantly, platform-controlled execution. AI helps us move faster with Flowgear. It helps new users get to a first working solution sooner. It helps experienced users avoid repetitive build work. And it helps business users interact with integrations through natural language. But the integration logic stays where it belongs, inside Flowgear. That is the shift that we wanted to highlight today. Thank you.